Welcome to all of you. Today we discuss numerical practical problem 18 trapezoidal rule. Semester 6 Mathematics Honors CBCS. This is the C programming trapezoidal method problem 18. Write a C program to evaluate the definite integral for the function fx equal to cos 2px square plus x e to the power minus x square within the limits of integration 0 degree and 30 degree. Correct up to 5 decimal places by trapezoidal rule using 16 ordinates where p equal to r plus 2 divided by 5. Now first we discuss about trapezoidal rule. Trapezoidal rule, also known as trapezoid rule, trapezium rule, is a closed type 2 points Newton Cotes quadrature formula, and this is a technique for numerical integration, and that is approximating the definite integral a to b f x dx is equal to I, is the exact value I. Now this I equal to it plus et, say this it is the approximate value of the integration and et is the error term. This is the simple trapezoidal rule. The it equal to h by 2 bracket fx0 plus fx1. Here x0 equal to a, lower limit, and x1 equal to b, the upper limit, and the step length h equal to b minus a. And the error term et equal to minus h cube by 12 f double dash eta, where eta lies between the open interval ab. The degree of precision of the trapezoidal rule is 1 as error term is equal to 0 when fx is a polynomial of degree 1. What is the degree of precision? Degree of precision or degree of accuracy of a quadrature formula is the least positive integer k such that the formula is exact. That is when error term equal to 0 for any polynomial of degree less than equal to k. But there exists a polynomial of degree k plus 1 for which it is not exact, and then it is error term not equal to 0. Obviously, this is the error term, this f double derivative eta. So obviously, when fx is a polynomial of degree 1, that is when fx equal to say 5x. So f dash x equal to 5, f double dash x equal to 0. Obviously, error term equal to 0, and then the this is exact, that is it equal to the exact value I. Geometrically, and this is the horizontal x-axis, the y-axis, and this is the curve y equal to fx. This is the curve y equal to fx, and this is the straight line. This is the point A. So this point is A comma fa, and this point B. So this point is B comma fb. The curve y equal to fx in the blue color is replaced by a straight line joining the points AFA, this point, and BAB, this point, and the area of the region bounded by x equal to a, this x equal to a, and x equal to b, and the above line, this red color, and x-axis represents this approximate value of the integral, and this is the trapezium, and hence the name trapezoidal rule. The composite trapezoidal rule, uh, uh, it is used in the C programming. This rule divide the range of the integration AB into n number of subintervals by n plus 1 ordinates or nodes. This x0 equal to a, x1, x2, xn equal to b. Apply the trapezoidal rule in these n subintervals. This x0, x1, x1, x2, and so on, x2, x3, and so on, xn minus 1, xn, and adding all, we get this I trapezoidal equal to h by 2 fx0 plus fx1 plus h by 2 bracket fx1 plus fx2 bracket close plus dot 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 plus h by 2 bracket fxn minus 2 plus fxn minus 1 bracket close plus h by 2 fxn minus 1 plus fxn, and that is compactly we write this I trapezoidal for composite uh, rule, this h by 2 bracket fx0 plus fxn plus 2 into fx1 plus fx2 plus dot 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 fxn minus 1. Actually we apply and this method in the C programming, and this is the last the error term for composite rule. This is the minus b minus a whole cube by 12n square f double less eta a less than eta less than b. Now back to the problem. This include stdio.h has include math.h because we use the here cost function, exponential, pi are all math header file. And this is the first we define the pi. This is the floating type and this is the constant. So we first define constant floating type pi equal to 3.1415925, and the function definition is this. This function is the argument is x and p, because here this function this p depends on p, so p equal to r plus 2 by 5 and this p. And main program the floating variable a b h p and x one dimensional array 25 and sum in integer type variable in I and r. First we print enter the value of r, enter the lower limit a, and notice that this lower limit is 0 degree and upper limit is 30 degree. So lower limit a in degree and the upper limit b in degree. Enter the number of ordinates. Here number of ordinates is 16 ordinates. So number of ordinates and this, and so obviously this n equal to n minus 1. This n minus 1 actually the number of subintervals. This n minus 1, and so we print this number of subintervals, that is equal to n, say revised value of n equal to n minus 1, that is actually we use this value n minus 1 which is equal to n number of subintervals. Now first we convert this degree to radian by using this formula a equal to pi into a by 180.0. Be careful for this. B equal to comma b equal to pi into b by 180.0 semicolon, and this is the conversion of degree to radian. And this pi equal to r plus 2 by 5.0 because it is given that p equal to this value of p. And next h equal to the step length b minus a by n. N is the number of subintervals here. Now initial sum equal to 0.0. Now print this subinterval x fx x plus h fx plus h and the sum. For I equal to 1, I less than equal to n, I plus plus. And float type variable x0 and x1. Initially x0 this equal to a, and I equal to 1. When I equal to 1, this 1 minus 1 this is 0, so x0 equal to a, and x1 equal to x0 plus h. So sum equal to new sum equal to previous sum is 0, so new sum equal to 0 plus h by 2 fx0 plus fx1. So from this the simple this h by 2 fx0 plus fx1 when I equal to 1, and print this I x0 fx0 x1 fx1 and sum. Next for I next loop next for I equal to 2, I equal to 2 this new x0 is this this a plus I equal to 2, so 2 minus 1 that is 1 plus h. Actually this new x0 actually is the value of x1, and this x1 is improved value of this x1 plus h, actually this x1 actually x2. So when I equal to 2, this x0 actually x1 and this x2 actually x2, so x1 and x2, and sum equal to new sum equal to previous sum. Previous sum means the previous sub interval sum, sum in the previous sum interval x0 and within x1, this sum, and plus h by 2 fx1 plus fx2. So this fx0 actually fx1 and this x1 equal to actually fx2. So we write this h by 2 fx1 plus fx2. So we get this sum, previous sum, plus this new sum. So total new sum is this plus this this subinterval x0 within the x0 and x1, and this sum is x1 and x2. Next, when I equal to 3, so this x3, so a plus 3 minus 1 into h, that is 2h, a plus 2h. So this is actually x0, actually x2, and this equal to x3. So next subinterval x2 and x3. So this sum is the previous sum. Previous sum means within the interval x0, x1, and x1, x2. This sum adding with the new sum, this h by 2, this fx0, fx1, actually this fx2 and fx3. So this the improved sum equal to previous sum plus within the interval this. So this sum plus this sum plus h by 2, fx2 plus fx3. And in this way we get all the sums actually, and this print this, and the value of the integral is this, actually the correct up to 5 decimal places. First save this program and compile and run this program. Enter the value, enter the value of r, this equal to 0. Enter, and this lower limit in degree, actually 0 degree in the problem, and enter the upper limit v in degree, actually this 30 degree, and enter the number of ordinates, actually this is the 16 ordinates. And so number of subintervals is 15. So subinterval, this is the first column is the subinterval column. This first subinterval, actually this means x0 and x1. This is x1, x0 value of at the point x0, this value of fx0, and this x1 a value of fx1. So this sum is h by 2 x0 fx0 plus fx1. Next second subinterval, this sum x1 and this value of fx1, and this sum x2, this value x2, and this value of fx2. So this sum actually the sum of this subinterval x1 and x2 plus the previous sum, this previous subinterval sum, this. So actually this second subinterval sum actually first subinterval plus second subinterval sum, and in this way there are 15 subintervals. So last we get this value 0.491679. Actually this is the required value of the integration is this. This is the correctness of this up to 5 decimal places. Thank you for watching this video.